as one Harvard professor is raising the theory this may actually be a piece of alien technology.
The universe just got more frightening. A Harvard scientist has discovered that 3I/ATLOS is shedding metallic alloys never seen on Earth. These alien metals have no match in our laboratories, raising a terrifying question. Is this natural, or is it something built? The answer could change everything we thought we knew about space. The visitor from beyond and the iron of the sky. In late 2017, astronomers were surprised by an unusual discovery in the field of astronomy. They observed an object that was entering our solar system at a high speed, unlike anything they had seen before. This object was moving at a speed of almost 26 kilometers per second in relation to the Sun, coming in from above the ecliptic plane, 019 to 028. Initially, it appeared to be a typical asteroid, but as time passed, its unusual characteristics started to become apparent. The object was called Oumuamua, and the way it acted made it stand out. When it got closer to the Sun, something strange occurred. Instead of continuing on its path like normal, it started to speed up a little. Typically, comets speed up because they release gas and dust when they get heated up, which propels them forward. However, Oumuamua did not leave behind any gas or dust. There was no tail, no cloud, no visible evidence of gases being released. Its movement was not like anything seen before. Researchers examined the brightness variations of the object and found that it was elongated, possibly 10 times longer than its width. Some thought it resembled a rotating cigar, while others likened it to a flat pancake. It completed a full rotation every 8 hours, but the specifics of its shape raised further uncertainties. The acceleration of the object posed a real challenge, as the typical explanations did not align. If the pressure from sunlight was responsible, then the object had to be incredibly slim and lightweight, much thinner than any known space rock or ice. A shocking finding caused a lot of attention from the media. News articles talked about a strange visitor, and some wondered if it was from aliens. A Harvard astrophysicist named Avi Loeb suggested Oumuamua might not be completely natural. He thought it moved like a solar sail, which is a very thin object that can travel on starlight, 111 to 120. This idea interested many people but caused disagreement among scientists. Many astronomers disagreed and offered alternative theories, such as unconventional forms of ice or unique dust particles. However, none of these explanations fully explained all the data. The argument escalated, moving beyond academic circles to news outlets and public forums. Avi Loeb openly supported his idea, even publishing a book that gained global attention. Scientists were most concerned about the speed at which the object was moving and the fact that it did not have the typical characteristics of a comet or asteroid. It had no tail, no coma, no chemical signals, and its shape was unlike anything seen before. It seemed like it came from a totally new category that Earth had never seen. Sadly, Oumuamua left our solar system fast, disappearing before telescopes could get a good look at it. Observatories spent months scanning the sky in hopes of finding another similar object, but nothing turned up. The mysterious occurrence made a lasting impression. The unusual behavior of one interstellar visitor raised questions about other unknown objects traveling through space. The main takeaway was that the solar system is not alone or peaceful, but a part of a larger area where surprising visitors can arrive unexpectedly. Some of these visitors may not conform to the expectations of astronomers. Before telescopes were invented, people already stared at the sky with amazement. They believed that special objects sometimes fell from the heavens. In ancient Egypt, iron was considered precious and mysterious. Excavations from over 5,000 years ago uncovered small iron beads buried alongside gold and gemstones in a cemetery called Gerzeh. These beads were intricately crafted, and when tested with modern technology, they were found to contain a high percentage of nickel, indicating they came from meteorites carrying elements from space. The tale did not finish there. Many years later, a new valuable item surfaced in one of history's most well-known tombs. In the burial chamber of King Tutankhamun, a dagger with a gold handle and iron blade was found among the treasures. Its origins were questioned for many years. However, recent testing confirmed that the blade was made from nickel and cobalt arranged in a pattern found in meteorites, not on Earth. The crystal structures within the metal also indicated that it had cooled down gradually in space, a process impossible to replicate on Earth. The blade was carefully crafted at cool temperatures to protect its fragile details. It was not just a tool, but also a symbol of importance. During that era, meteoric iron was considered more precious than gold because it was believed to be a divine material meant only for royalty and deities. Throughout history and science, the same message is heard repeatedly. The sky has always brought mysteries to Earth. The firestorm of a kilonova. Kilonovas are incredibly violent and stunning occurrences in the universe. They are not your typical stellar explosions. Instead, they are much more intense, powerful, and have the ability to produce elements in a way that regular stars cannot. These events start when two neutron stars, extremely dense objects, move towards each other and eventually crash. The energy unleashed during this collision is almost unimaginable. The resulting explosion rips through space, dispersing heavy atoms over great distances and spreading the densest matter ever observed throughout the galaxy. In 2017, astronomers watched as a rare event unfolded in the sky in real time. It all started when the LIGO and Virgo observatories detected a gravitational wave event. This was followed by a bright optical flash that lit up the sky. Telescopes like the Very Large Telescope in Chile quickly picked up clear signals hidden in the light. They found the presence of strontium, a newly created element from the explosion. This was the first direct evidence that neutron star collisions create heavy elements. This process, called the R process, involves rapid neutron captures that can create atoms heavier than iron in a matter of seconds. Nickel is one of the things formed during this chaotic event. After a kilonova, the rapid neutron capture process adds neutrons to the nuclei of lighter elements, like those in the iron group. This produces unstable isotopes of nickel, which eventually decay to release energy and fuel the bright aftermath. The amount of nickel produced in comparison to iron is determined by various factors such as the number of neutrons present, the speed at which the material expands, and how much debris manages to escape the gravitational pull of the merged star. Scientists believe that certain areas of the debris may have high concentrations of nickel, but little to no iron, while other areas might have unusual and uneven ratios that are not typically seen in regular supernova explosions or on Earth. This isn't the gradual process of metal production seen in dying red giant stars. Instead, it's a much more intense event, a cosmic furnace burning brightly for a brief moment before slowly cooling over millions of years as the debris floats through space. The kilonova process gives rise to unique metals found in some interstellar objects. If one of these objects originated from the aftermath of a neutron star collision, its chemical composition would be unlike anything found in our solar system. The lack of iron and abundance of nickel in GGW 170817 aligns with predictions from certain models. The presence of strong strontium signals in the light from this event, which is not typically produced in supernovae, further supports the idea that neutron star collisions create unique elements. What sets these collisions apart is the extreme speed and violence at which they occur. While regular supernovae produce iron and nickel in expected amounts, kilonovae often create unexpected elemental combinations due to the chaotic nature of the event. Astronomers are now comparing the ratios of nickel to iron and debris that is associated with mysterious objects like 3I/8 Oamon Usbas TLAS. The numbers they have found are unusual but still within the realm of possibility. Some simulations suggest that clumps rich in nickel and poor in iron can form in the twisted tails of a merger event. These clumps can cool down, turn into dust grains, and travel through the galaxy for billions of years. If an object like 3I originated from one of these clumps, it would have a unique chemical signature that sets it apart from any comet, asteroid, or meteorite formed in our solar system. Even small things like the sudden increase in carbon dioxide that powerful telescopes have observed could be understood in this narrative. Some theories suggest that the materials produced by a particular type of nuclear reaction, after floating through space for many years and getting hit by cosmic rays, may form unstable layers. These layers are only visible when the object approaches a star and then emits gases into the universe. This is a natural process that doesn't need any planning or manipulation, just the unpredictable forces of nature at their most extreme. The kilonova event is a dramatic celestial event. It occurs when two neutron stars collide, creating new elements that are sent out into space as the foundation for future planets. In the case of the object known as 3I, its unique elemental composition suggests that it must be a rare phenomenon. This object would have to originate from the core of a neutron star merger, travel across the galaxy for a long time without changing its exotic chemistry, and eventually reach our solar system. It is a simple yet impressive explanation. It limits the options for what could produce these unique metals. The solution can only be found in the most intense environments in the universe. The explosive core of a kilonova, the silent messenger in the sky. The unusual object known as 3I/Atlas is not just aimlessly floating through space like a regular rock. Its movement is peculiar, seeming to have a purposeful trajectory. Its path is almost flat, only slightly tilted compared to the plane where most planets orbit. However, it is unique in that it is moving in the opposite direction, known as retrograde, which sets it apart. This unusual motion causes it to not simply pass by at a far distance. Instead, it comes close to the orbits of the inner planets, almost as if it is purposefully moving through them, inspecting each one carefully as it goes along. The timing of the journey of this object adds an extra layer of mystery. It approaches the sun when it is on the opposite side out of view from Earth. This makes it difficult to observe and study when it is at its brightest and closest. Some people find this timing suspicious, suggesting that the object may not want to be closely monitored. It's almost as if the object is intentionally avoiding close scrutiny. If someone wanted to quietly study the object, this would be the ideal way to do it, being visible but ensuring that the closest moment remains elusive. Some scientists believe that the universe is huge and uncommon events occur by pure luck. They argue that bizarre paths and unusual orbits are just part of the randomness of the universe. However, there is a strong opposing viewpoint. Even though the chances of these events happening are extremely low, let's say 1 in 20,000, we have already observed 3 interstellar objects in a short period. This makes things seem unusual. The pattern doesn't align with the idea of random chance. Avi Loeb, a scientist who has researched these puzzles extensively, sees a strange combination of missing iron, excessive nickel, and a unique orbit as a series of clues. While each clue alone may not be significant, when put together they bring up questions that are hard to dismiss. He does not assert that it is definitely a probe, but suggests that it is worth exploring the idea that this object is more than just a piece of rock. If the object's path is deliberate, then 3I/Atlas may not be a random visitor after all. It could potentially be a form of communication or a messenger. This concept continues to spark discussion. If the object is indeed traveling on a specific course, it implies that it was purposely sent and meant to reach this location, close to these planets, during this particular time. This is why Loeb is advocating for additional information, thorough examination, and a more detailed investigation into everything related to 3I/Atlas. If the rare materials are authentic and the data genuinely indicates intentional creation, then this object might serve as a hint that alters humanity's perception of its position in the cosmos. The idea of receiving a message from outer space is not as far-fetched as it may seem. Back in 1977, NASA sent out Voyager 1 and Voyager 2, both containing a special golden record. These records included music, greetings in various languages, and information about Earth, all engraved onto a disk designed to survive for billions of years. They were placed inside spacecraft and sent beyond our solar system in the hopes that they may one day be found by beings far away. The golden records were like a message in a bottle thrown into the vastness of space, a representation of humanity at that particular moment in time. The comparison between Voyager and 3I/Atlas is evident. Voyager was a project by humans to communicate with outer space, while 3I/Atlas could be a similar message from a different planet. Unlike Voyager, 3I/Atlas does not have any physical grooves or disks to convey its message. Instead, its message could be encoded in its chemical composition, metals, and structure. This could include a unique balance of elements, unusual ratios, or rare isotopes as part of its design. Rather than using a voice or radio signal, 3I/Atlas would be a silent archive meant to last longer than words, containing meaning within its material itself. If this is accurate, then every part of 3I/Atlas could be important. The lack of iron, extra nickel, strange carbon dioxide covering, and specific orbit could all be hints. It might not be just a comet. It could be a time capsule from a different star system, sent to float until it was discovered by the correct observers. The golden record was created with the belief that someday someone would be able to understand it. If 3I/Atlas is similar, then it may not be here by chance. It could be holding the history and essence of another world, hoping that we will take notice. The story of 3I/Atlas is made powerful by the idea that it could be a unique visitor from space or a messenger from another civilization. The answer to its true nature is hidden in its path, its composition, and its quiet presence. Until the truth is revealed, the mystery will linger, reminding us that the universe may not be as silent as we believe.